And our lesson today is on congruent figures. So we're covering two sections of our textbook. This is from 3.2 and 3.3, and I just combined them into one lesson. I think I was supposed to change one of those essential questions because I kind of feel like it's odd if they're the same. Maybe I made a typo. I'll have to go back and check that. But definitely one of your EQs is how can you determine whether two figures are congruent? And then we have some I can statements. These are learning goals. I can determine whether two figures are congruent using rigid motion transformations. So we learned about rigid motion transformations before break. In case you forgot everything, a rigid motion transformation is a translation, which is a slide. It is a reflection, which is a flip, or a rotation, which is a turn. Okay, so those three transformations are rigid motion transformations. I can determine if two triangles are congruent using CPCFC. This set of notes will kind of touch on that, but we'll get into that more. Congruent, corresponding parts of congruent figures are congruent is what it stands for. Okay, and that's in the notes, so don't worry about trying to figure that out right now. Next learning goal, I can use the definition of congruence to find missing parts of a figure. All right, so if we know that two figures are congruent, we can find missing parts on one or the other, just knowing that they're the same shape and size. And then I can infer which parts of congruent triangles are congruent. Okay, so if you have two triangles, you know they're congruent. What does that mean? Like which parts are the same, have the same measure? And so this is your vocabulary. We have what does it mean to be congruent first. That's having the same size and the same shape. So, you know, if you have an image on some type of document and you copy and paste that image, those two images are exactly congruent. They're the same size and shape. You can move the image around the paper, that's translation. You can turn that image, that's rotation. You can flip it. They're still congruent because they're the same size and same shape. Congruent angles are angles that have the same measure. So if one angle is measured at 47 degrees, then your other angle that would be congruent to that would also have a measure of 47 degrees, same measure. The word corresponding, that means to appear in the same place in two similar situations. Okay, so if you have like one right triangle and then another right triangle, and we're talking about the same right angle, okay, those would be corresponding angles. When you have congruent figures, those are two plane figures whose corresponding sides and angles are congruent. So when two figures are congruent, then their sides are the same measures and their angles are the same measures. And we had an activity before we went on break where we were kind of just playing around with what it means to be congruent. If you remember, you were given 6 different shapes, and then you had to drag the top ones down and maybe turn them or flip them so that they would match up with the 3 at the bottom. Okay, so we were matching congruent figures already. You've seen this a little bit. And then I put the congruent symbol up there for you. It's a little wavy symbol, and then under that you have the equal sign. All right, and so if you kind of break it down where that comes from, just the little wavy symbol by itself, that is the symbol for similar, okay, which means the same shape. If something is similar to something else, they don't necessarily have to be the same size. One could be larger and one could be smaller, but they have to be the same exact shape. And then underneath that, you have the equal sign, which means equality, okay? So same shape, same size, that's congruent. That's where the congruent symbol comes from. Okay, so rigid motion transformations. Two plane figures are congruent if and only if one can be attained from the other by a sequence of rigid motions. And so we've learned this before. This is review. The transformations that are rigid are reflections, rotations, and translations. And so these are also known as congruence transformations. They keep shapes congruent because they are rigid transformations. Okay, and so I just put a few of the little rules right here. This is just a little graphic organizer for reflection. Two of the common reflections are listed over the x-axis and over the y-axis. This is how you change your ordered pairs so that you would be doing this type of a transformation. The other two you need to know are not listed here. There's just a couple of them listed here. You would also need to know over the line y equals x and over the line y equals negative x. And those are all in your transformation cheat sheet that I gave you guys before we went on break. Okay, so rotation, 180-degree rotation. This is just one example. We have, many rotations. You could do 90 degrees, you could do 270, you could be going clockwise, counterclockwise, but here's just one of them, 180-degree rotation. And then where you're rotating around, 0, 0, that's the origin. So x, y changes into negative x, negative y. So if you had the point 3, 5, it would change into the point -3, -5. And then the last one here, that is a type of transformation that makes figures keep their congruence, is a translation. Okay, this is a slide. And so this is actually something that later this week on Friday, we're going to be practicing a little more with that notation, because almost everybody, I think there was one student who got it correct. Almost everybody missed the first question on the retest, where you had to write the coordinate notation for translations. And what you had to do was, if you're translating A units left or right and B units up or down, given an original point, this is the general version of it, x, y, then you're adding A to represent going to the left or right. A could be positive or negative. So if A is a positive number, you're going to the right. If A is a negative number, you're going to left. You might even have x minus a number. That would mean moving to the left. And then for the y coordinate, you're either moving up or down. So B units, are you moving up or down? Are you adding a positive number to move up, or are you adding a negative number to move down? Okay, sorry, there's a lot of me talking, and then I do have slides for you guys to do. Rigid motion transformation. So two plane figures are congruent if and only if one can be obtained from the other by a sequence of rigid motions. And so we looked at that graphic organizer on the last slide. Those are the three types of rigid motions. And so if we look at this picture, the two figures appear to be the same size and shape. So look for a rigid transformation that will map one to the other. You can map C, D, E, F onto J, K, L, M by reflecting C, D, E, F over the y-axis. Reflections are rigid motions. Okay, so that means that these two figures are congruent. And the notation for that reflection over the y-axis is you take x, y, and it turns into the opposite sign of x, and then y stays exactly the same. Okay, so your turn. And I'm just going to put on student paste. All right, so I'm going to give you about 5 minutes. So I am going to turn off student paste just because I want you to come back to the Google Meet so you can see what some of your peers wrote, because you guys came up with some really great answers. And remember, it's anonymous in case you forgot. So, and 18 of you did respond. So I'm going to show some responses here. Yes, because they're a mirror image of each other and they have the same shape and size. Absolutely. They're congruent because they look like a reflection, and the shape could be moved to make a reflection by a sequence of rigid motions. Okay, nice use of vocabulary. Good job. Yes, they are the same shape and side lengths. Absolutely, this is the definition of congruence. These figures are congruent because they both have the same shape, length, and size. If you were to reflect the x-axis, they both land and become the same shape, which makes them congruent. Absolutely. Yes, it is a reflection of the x-axis. Good. Figures are congruent. They're the same shape and size. They're congruent using the reflection formula because this is a reflection across the x-axis. So those are all amazing answers. You guys did really good. And so what we're going to do now is go to our next slide together, which is slide 6. And at this point, you could either be in our Google Meet or you can be on your Pear Deck tab, okay? So it doesn't matter. You can hear me explaining it. This is called CPCFC. This is what was in our learning goal. And it's just this long abbreviation for corresponding parts of congruent figures are congruent. Okay, so what that says, what that means is if two figures are congruent, then the corresponding sides are congruent. Corresponding means in the same location, but just in a different figure. So like you can see there's like a 1 tick mark between the side length BC, and then if you look over at the side length EF, there's also 1 tick mark. This shows they are corresponding and they are exactly this, they're congruent, they're the same length. And then the other sides that are congruent would be AB is congruent to side length DE. They have double tick marks, okay, that shows they are the same length. And finally, side length AC is congruent to side length DF. They have triple tick marks, which shows they are the same length. So that's half of it. If two figures are congruent, then the corresponding side lengths are congruent. The corresponding sides are congruent. And also, the corresponding angles are congruent. So there's 3 angles in each triangle, and they match up. They correspond. They are congruent in this situation. So angle A is congruent to angle D. The measure of angle A is the same as the measure of angle D. Angle B is congruent to angle E because the measure of angle B is the same as the measure of angle E. Angle C is congruent to angle F because the measure of angle C is the same as equal to the measure of angle F. So this is basically what we call CPCFC. Corresponding parts of congruent figures are congruent. Now, the reason we have this little abbreviation for this is that next week we're going to start doing some very basic proofs where we're going to prove things to be true. And sometimes we're going to use this theorem that corresponding parts of congruent figures are congruent. So instead of having to actually write out corresponding parts of congruent figures are congruent, we can then just shorten it by saying by CPCFC. And that's a quicker way to write a proof. Our proofs won't be very long. Okay, they're going to be in a table. You'll be able to handle it. And then down at the bottom, the notation for what we have is triangle ABC is congruent to triangle DEF. And it is important, the order of the letters. Okay, so don't forget that. The order of your letters are important. You want to make sure that, like, see how A and D are both written first because they are the two that are corresponding. And then B and E are both written second because they are the two angles that correspond. And then C and D are both written last because they are the two angles that correspond. All right, so basically still just looking at CPCFC on this slide. If two figures are congruent, then corresponding sides are congruent and corresponding angles are congruent. That's the same thing it says on the last one. That's a theorem. It's called CPCFC. And so you can kind of go through and this is kind of neat because it has symbols that you might see, mathematical symbols, and then it has the words, like how you would read that out loud, and then it shows the meaning of that. So like for the first one, those symbols that you see, the first row, the way you would read that is the words. It's side AB is congruent to side DE. And what that means is that the side of triangle marked AB and the side of triangle marked DE are the same length. So that's for the side lengths, congruence of side lengths. And then some other common symbols you would see would be with those angle symbols and the congruent symbol. The way you read that one is angle B is congruent to angle E. So the words tell you how to read the symbols. And the symbols are nice because it's less writing. Okay, that's one nice thing about math is like you can really not have to write a lot. You don't have to write out full sentences. You can start using your symbols accurately, and it's like learning a new language. Okay, and then the meaning of that is that the angle marked by corner B and the angle marked by corner E have the same measure. So, you know, by writing out that whole sentence that I just read, you could instead just write those symbols all the way to the left, and it means exactly the same thing. It's just way more concise and to the point. And then the last row there, the triangle symbol, ABC. Okay, so the way you read that is triangle ABC is congruent to triangle DEF. Notice that in all of the words column is congruent to. Every time you see the congruent symbol, that's the way you read it, is congruent to. And then the meaning of that is that the triangle ABC and the triangle DEF have the same shape and size. So if you wanted to write out like everything over in the meaning column, all those words, and that's a lot of writing. But instead in mathematics, you can go all the way over to the symbol side and just put those symbols and it means exactly the same thing. That's one of the things I like about math is you don't have to write a lot once you learn how to use the notation correctly. All right, and again, just looking at what CPCFC is, it's kind of like another example. When two figures are congruent, the corresponding sides and corresponding angles are congruent. So there's two triangles for you. We have triangle ABC and triangle DEF. Now it's telling us they are congruent. So since we know they're congruent, we can then deduce all of that notation. And what it says is it's a list of the side lengths. There's 3 pairs of side lengths that are all congruent to each other. And there's also 3 pairs of angles that are all congruent to each other. Because it said that triangle ABC and triangle DEF are congruent, I could deduce those last 2 lines of notation. Conversely, then also if I had these last 2 lines of notation, I could deduce the previous statement that the 2 triangles are congruent. Okay, so now on this one, and I'm probably going to give you guys, let's see, where are we at in time? We have till 10. So I think there's 3 more slides, or 2 more slides. How many slides are left? I'm going to turn you on to student pace. We're on 9 of 11. So 9, 10, 11. You have 3 slides, 10 minutes to do 3 slides, and then we'll go over it all in the last 5 minutes. All right? And so you can go back through and look at things. On this slide, right side XY is the same length as side GH in symbols. All right, you can use your mouse to do that, or you may be able to type some of it and then just go back with the pen tool and write the rest of it. And then drag the red star to the graph with 2 congruent triangles. And it's given that triangle PQR is congruent to triangle STU, write the corresponding angle or side. The first one is done for you. All right, so you have those 3 slides to do until 9:55. And then what I'm going to have you do is just come back to our Google Meet, okay, because I do want to show you what other people are writing, what the correct answers are, and then you'll have a chance to go back and adjust your answers if you need to. So It's 9:55. I'm going to stop student pace. Go ahead and come back to our Google Meet tab. You don't have to close Pear Deck, just come back to our tab. And so for slide 9, it says right side XY is the same length as GH in symbols. And so here's an example of a correct response. This is side XY is congruent to GH. Yeah, there's no congruent symbol for you to type, so you would have to make it, and they did a good job there. This person just chose to draw the whole thing, which is great. Side XY is congruent to side GH. So that's exactly what you want to do on those ones, okay? Here's another good example. Notice that the X and the Y and the G and the H are all capitalized because they're given to you as capitalized, so you don't want to change your case. That's very important. If we look at slide 10, drag the red star to the graph with 2 congruent triangles. I'm very proud of you guys because those of you that tried this, look at that. You all got it right. This is definitely the correct side. So now someone's trying to be funny and move it to the wrong side. Someone else is a comedian. But if you look over here, these two triangles are not the same size. So they may be similar, but they are not congruent. So these are congruent triangles on that side. And then your last slide, this is the most challenging. I found someone who did it perfectly, okay, and not, it says 11 of you tried it. So some of you were maybe halfway, but I did find one person did it perfectly, so good job to this person. They put all the corresponding sides and angles in the correct, they're capitalized, they're the correct letter, and they did use all the correct symbols, a little line on top of the 2 letters and the angle symbol. Now, sometimes with these, they can get a little tricky, especially if the picture you're looking at, you don't know if it's been rotated or something, or maybe it is rotated and you're trying to think about it in your brain. One thing that's really easy to do this is look at the order. If they give you what you have here, triangle PQR is congruent to triangle STU. These letters are already ordered so that they're congruent. So P matches with S, Q matches with T, R matches with U. So when you come over here to do the angles for T, well, I know that T is in the middle, so I need to use the corresponding letter in the middle, which is Q. S is at the beginning, so I need to use the letter at the beginning on the other triangle, which is P. U is at the end, so then I have to use R. And then the same thing for the side lengths. P, Q, well, that's the first 2 letters. First letter, second letter, so ST. QR, the last 2 letters, QR, so TU. RP, it's the last letter and then the first letter. Same thing here, the last letter and then the first letter. The order is very important when you're writing congruent statements. So if you have 2 letters you have to write down, you have to make sure you have the correct order. And then again, with the angles, you have to make sure you're matching these up to the one that matches with it. All right, so I am going to turn this to student paste. That gives you a chance to change your answers if you needed to. And I'm going to launch a poll for you just to see how you feel about today's lesson. Okay, you have 4 options. You're just going to pick one of them real quick. It's in the Google Meet.